All right, and so we start by talking about the inner planets. The inner planets all share some common features. Mercury, Venus, Earth, and Mars all have rocky surfaces that are composed mainly of silicates and metals. So silicates meaning just compounds that contain the element silicon. In fact, the most abundant element in Earth's crust is silicon. All of the inner planets tend to be smaller and denser, again, because they are made of rock. They tend to have very few moons, and almost all of them have atmospheres. This image right here is actually kind of nice because it shows the size of the inner planets to scale. So Venus and Earth are basically the same size. A lot of times Venus is called Earth's sister planet. But one thing that tends to surprise people is that Mars is actually significantly smaller than Earth. Now we do a lot of studying of Mars and like looking for life there, so a lot of times we think it's more similar to Earth, but it's actually quite a bit smaller. The reason we do most of our studying on Mars is because it's easier to get to than most of the other planets. So first up of the inner planets closest to the sun is Mercury. Mercury is located about 0.4 AU from the sun. So a little bit less than half the distance of the Earth to the sun. The eccentricity of its orbit is 0.205, so it's decently elliptical. And it has an albedo of 0.11, same as Earth's moon, which is, not very reflective at all. And again, its surface is very, very similar to the appearance of Earth's moon, in that it's very gray and dusty and rocky and covered with lots and lots of craters. Being so close to the sun, Mercury's been impacted a lot, and Mercury hasn't had any active volcanism, so there hasn't been active volcanoes on its surface. And there's no atmosphere, no wind or water to wear away craters. So basically any impact crater that is on Mercury just stays there. Mercury also does not have an atmosphere. Now, it does have a very, very thin, what we call exosphere, where, the sun basically kind of vaporizes some elements on the surface, but that vapor tends to be lost also to space. So it's a very, very thin exosphere, which is essentially no atmosphere. Mercury also has no moons, and it experiences huge daytime and nighttime temperature swings. Again, it has no atmosphere, so when it's facing the sun, the side of Mercury that's lit by the sun is really, really hot. We're talking 800 degrees Fahrenheit. And the side of Mercury that is shaded or away from the sun is incredibly cold, negative 296 degrees Fahrenheit. Those are your day and night temperatures on Mercury. And this is another image of Mercury. This is its southern hemisphere. And again, just absolutely riddled with craters. So next up we have Venus, a lot of times called Earth's sister planet. There was a time before we learned a lot about Venus that scientists thought that, it might be like a second Earth, where it would be really lush and wet and green, like a huge jungle, because of its incredibly thick atmosphere. However, it turned out that was absolutely not the case. Venus is located 0.7 AU from the sun, and it has an eccentricity of 0.0068. So Venus's orbit is really close to a circle. It's not very elliptical at all. Its albedo is 0.65, which I believe it's definitely the highest albedo of any other planet. There might be one moon in the solar system that is more reflective than Venus, but it's just about. And it has a very rocky surface, but it's covered with there's mountains, there's volcanoes, there's canyons, and it has a really thick atmosphere. Venus does not have a moon, Its atmosphere, though, is mostly made of carbon dioxide, CO2, and sulfuric acid. So at one point in Venus's history, it might have been a more hospitable place. However, scientists believe that Venus experienced a runaway greenhouse effect, where essentially volcanoes put a lot of carbon dioxide into the atmosphere, which heated up the planet because it retained more heat. That increasing heat caused more water to evaporate. Water vapor is also a greenhouse gas. Then it gets hotter. More of the water evaporates, it gets hotter and hotter, and eventually you just get this insanely hot hellscape of a planet where surface temperatures on Venus are hot enough to melt lead. And the atmospheric pressure, because the atmosphere is so thick, it's basically the same as if you were a mile under the ocean. So think about how much water pressure that would be. That's the same as just the pressure the air on Venus is going to put on you. Which is why it tends to be really hard to put like any kind of robots on Venus, because they have to be able to withstand these insane temperatures and pressures, and the fact that the air itself is full of acid. So there was it was a long and bumpy road to doing basically landers on Venus. A lot of the early exploration of Venus was actually done by the Soviet Union's Venera program. And most of our surface maps of Venus nowadays have been made via like radar. And then of course we have Earth, the most familiar of all the planets to it. Earth is 1 AU from the sun because that's how we define an astronomical unit. It's the distance from Earth to the sun. Earth has an eccentricity in its orbit of 0.0167. So again, not very eccentric, much closer to a perfect circle. Earth's albedo is 0.367. So pretty decent, again, because we have an atmosphere with white clouds that can reflect sunlight. And of course, we have a dynamic and rocky surface that is mostly covered by liquid water. And we have just one moon. Our very thick atmosphere is composed mainly of nitrogen gas, N2, and oxygen gas, O2. And Earth's one claim to fame is that it's the only planet that we know of that has life, at least for the moment. And I included the image from Apollo 10's view of the Earth. There's just something about these images of Earth from the moon that are really beautiful. And now we have Mars. Mars, our planet inhabited entirely by robots. Mars is located 1.5 AU from the sun. It has an eccentricity of 0.0934 and an albedo of 0.15. So it's not very reflective. And it has a very, very dusty surface, but one that is also dynamic. There's lots of mountains and canyons and volcanoes. Mars is red because a lot of the rocks on Mars contain iron oxide. And so when iron oxidizes, you get that orange-red rust color. And we do know that Mars at one time had liquid water on its surface, and actually a lot of liquid water on its surface. Mars, today, it has an atmosphere, but it's a very, very thin atmosphere. It's mostly made of carbon dioxide, nitrogen gas, and argon. Mars does have two small moons. They're called Phobos and Deimos. I believe they're named after the horses that pulled the Greek god Ares' chariot. And Mars, one of its claim to fame is that it has the largest volcano in the entire solar system, Olympus Mons. So we're currently looking for signs of past or current life on Mars. That is the main goal of NASA's most recent rover, the Perseverance rover. And again, we think that we might find that because Mars used to have a lot of water on its surface. However, at some point, Mars lost its planet-wide magnetic field. And when it lost its planet-wide magnetic field, solar wind was able to penetrate to its atmosphere, and basically the sun has just been blowing away its atmosphere over time. And when there's less atmosphere, you can't hold on to water because it evaporates. Earth has a very, very strong magnetic field, and that protects our atmosphere from the solar wind. So that's our basic tour of the inner planets. Now we're going to look at the outer planets, and we're going to look at the most prominent moons from some of the outer planets. So outer planets share some similarities. Jupiter, Saturn, Uranus, and Neptune, they are typically referred to as gas giants because they don't really have a solid surface. Like, you can't really land on Jupiter. It's essentially a big ball of gas. In fact, if Jupiter had been able to get a little bit larger and get a little bit more gas, it could have become its own star. Their atmospheres, another similarity, is that pretty much all their atmospheres are mostly hydrogen and helium gas. Again, the same thing that stars are made out of. The difference between a gas giant planet and a star is a star has gotten enough gas and dust accumulated in it that nuclear fusion spontaneously starts in the core. But we'll talk more about stars next week. Outer planets tend to have lots of moons, and I think actually all of them have been confirmed to have rings. And again, this is a 2-scale by size picture, so you can see that Jupiter and Saturn are really quite large, and Uranus and Neptune are smaller in comparison to them. But they are all quite large compared to the Earth. So Jupiter is located 5.2 astronomical units from the Sun. It has an eccentricity of 0.0487, an albedo of 0.34, and again, we classify it as a gas giant, which means it has no solid surface. Now, while Jupiter's atmosphere is mostly hydrogen and helium, there are other trace compounds in it, and it's those trace compounds that give it its bright, colorful, and striated atmosphere. Of course, the most famous feature of Jupiter's atmosphere is the Great Red Spot, which is just a tremendously huge storm that has been raging for basically as long as we've been able to see Jupiter close enough to see the red spot. And this is just an image that shows the relative size of Jupiter compared to the Earth. So Earth is absolutely tiny compared to Jupiter. Again, like I said, if Jupiter had been able to get a little bit bigger, it might have become its own star. So again, Jupiter's colorful atmosphere, it's mostly hydrogen and helium with a few other trace compounds. It does indeed have some thin and very dark rings. So we first discovered Jupiter's rings when the Voyager spacecraft visited it. And if I remember correctly, we only saw them as Voyager was leaving Jupiter because they were so dark they didn't reflect a lot of sunlight. So it was only until Jupiter was backlit by the sun that we were able to pick out its very thin ring system. And this up here is an image of Jupiter's southern hemisphere taken by the Juno spacecraft, which I believe is still orbiting and studying Jupiter right now. So Jupiter has 79 moons. This is the most in the solar system. And I believe those are 79 confirmed moons. There are others that it may have, but we don't have enough data to mark them as yes, for sure, a moon. The 4 largest moons, Io, Europa, Ganymede, and Callisto, were first observed by Galileo in 1610. And because of that, we call them the Galilean moons. And they are really, really interesting bodies in our solar system. So we're going to take a little bit of a tour of each of these 4 Galilean moons. First up is Io. And Io is really interesting because it is the most volcanically active body in the entire solar system. So there is volcanoes and lava spewing on Io all the time. It's slightly larger than Earth's moon. And some of the lava fountains that like burst out of its volcanoes can be dozens of miles high. So like we can actually observe these like lava fountains coming out of these volcanoes from an orbiting spacecraft going around Jupiter. And this is actually, this image was taken by the Galileo spacecraft, which was one sent in, I believe, the 80s specifically to study the Jupiter system. Then we have Europa. Europa is really, really exciting to scientists who are looking for life outside of Earth. It has this frozen surface with lots and lots of cracks in it. And what scientists think is they think there is a huge moon-wide salty ocean underneath that ice. And again, when there's the presence of liquid water, there's the possibility that there could be life. And so there's a lot of people who are planning or trying to propose missions that would allow us to explore that salty ocean underneath Europa. Next up is Ganymede. Ganymede is the largest moon in the solar system. Not terribly surprising that the largest planet in the solar system also has the largest moon. It's also the only moon that has its own magnetic field. So most of the time moons don't have a magnetic field because they're simply too small. Because most planets, their magnetic fields are generated by some kind of molten core. But Ganymede actually has one. And again, it's because Ganymede has this metal core. Now, typically, something like Ganymede would still be too small to maintain like a molten core. Just over time, we would have expected it to cool off and then for the magnetic field to disappear, similar with Mars. However, because Jupiter is so incredibly huge and Ganymede orbits Jupiter, Jupiter exerts massive tidal forces on Ganymede and all the other moons, essentially kind of slowly stretching the moons a little bit over the course of their orbit. And that stretching and squishing of it keeps its core hot. And we think that there's a thin, like its surface is made of like thin ice. It also has a very thin oxygen atmosphere, which is another thing that makes it interesting. This photo was also taken by the Galileo spacecraft. Next up is Callisto. And Callisto is interesting because of just how incredibly heavily cratered it is. It's one of the most cratered bodies in the solar system, and it's the 3rd largest moon in the solar system. And scientists also think that Callisto might have a salty ocean deep beneath its surface, which again could possibly mean that it could harbor life. But this one would be much more difficult to study. And this actually shows us like a particular area on Callisto, the Asgard Basin. And literally all of these are impact craters. Every little divot here is an impact crater. Next up we have Saturn. Saturn is probably by far the most recognizable planet in the solar system because of its huge, bright, glorious rings. It's located 9.5 astronomical units from the sun. Its orbit has an eccentricity of 0.0557, and it has an albedo of 0.34. And we also classify it as a gas giant planet. Again, it doesn't have a true, like, solid surface. And again, here's kind of a comparison of Saturn compared to the size of Earth. Again, Saturn's still huge. Its rings, huge compared with Earth. Again, Saturn's atmosphere is mostly hydrogen and helium with, a few trace elements or trace compounds. And it has the largest and most beautiful ring system of any planet in the solar system. In fact, the rings of Saturn are so big and bright that you can view them with only the use of binoculars. So if you have high-powered binoculars, you will be able to see the rings of Saturn. Now, it won't be perfectly visible. It'll kind of look like, typically if you view a planet through a telescope or binoculars, it looks like a glowing dot. Well, Saturn will kind of look like it has like two Mickey Mouse ears kind of sticking out because of its rings. And it has 62 moons, and it has a lot of provincial moons too, ones that haven't been totally confirmed. It's honestly hard to, distinguish sometimes what's a moon on Saturn, around Saturn, and what's just a part of its ring system. And the interesting thing about this image here is if you look closely, you can see the storm at the pole of Saturn is actually shaped like a hexagon. Yeah, which is not exactly what we would expect. We would expect something circular. And I'm not sure if we've quite figured out why it's shaped like a hexagon. This image was taken by the Cassini orbiter, which its mission actually just ended 2 years ago. But it had been studying Saturn for, a couple of decades, I think. So one of the most interesting moon around Saturn is Titan. And that's because Titan is the second largest moon in our solar system and the only moon to have its own thick atmosphere. So basically, until we put a lander on Titan, which was part of the Cassini-Huygens mission, we didn't know what the surface of Titan looked like because we could not see through its thick atmosphere. And it turns out that it has a surface that has been shaped by having a liquid flowing over its surface. Very similar to how rocks on Earth have been shaped by water flowing over them. However, Titan, the liquid is not water, it's actually hydrocarbons like methane. So typically we think of things like methane and propane as gases here on Earth. Titan is so cold that they are a liquid. And basically, Titan kind of has its own version of the water cycle, but with methane. There's methane clouds, and methane rain, and methane lakes and rivers. And so it's very interesting because it's one of the few bodies we know of that has a liquid on its surface. And some scientists think that it might be worthwhile exploring Titan because perhaps it has life, but maybe just life that we don't know about. Life as we know it requires liquid water. But perhaps, some people speculate that maybe there is some form of life on Titan that can live in liquid hydrocarbons. And this is actually a series of images that were taken by the Huygens lander basically as it came through the atmosphere on Titan and landed there. Another really interesting moon around Saturn is Enceladus. Again, Enceladus has this bright, icy surface, a little bit similar to Europa in the fact that we think there's this saltwater ocean underneath it. The interesting thing about Enceladus, though, is that it might be easier to sample that ocean on Enceladus than on Europa. Enceladus regularly has jets of this water that shoot out of its surface. So kind of like geysers, except if geysers on Earth made it all the way out into space. So much larger than geysers we have here on Earth. I know there's a lot of scientists that would love to send like an orbiter that could just, fly through some of these geysers and take some samples. Enceladus is also the most reflective surface in the solar system. So it has the highest albedo, but I don't know exactly what it is. And yeah, so these are again both taken by Cassini. So this is the surface of Enceladus, and then again, this is the geysers or jets of water. Next up, we've got Uranus. So moving ever farther out into our solar system. Uranus is located 19.8 astronomical units from the sun. Its orbit has an eccentricity of 0.044 and an albedo of 0.3. Most of the gas giants have fairly similar albedos to each other. And again, Uranus has no actual surface, although a lot of times it's referred to as an ice giant rather than a gas giant. And that's just simply because it's so much colder than Saturn and Jupiter. Because Neptune and Uranus are so much farther from the sun than even Jupiter and Saturn, they are orders of magnitude colder than both of those planets. And we think that maybe that contributes to just the lack of anything really interesting going on with Uranus's atmosphere. It's very plain and uniform, as far as we know. Because we have only ever had one spacecraft that made it all the way out to Uranus, and that was the Voyager 2 spacecraft. And here's a relative comparison size of Uranus to Earth. So it's much smaller than Jupiter, but it's still a good size larger than Earth. So here we have Uranus's atmosphere is mostly hydrogen and helium, but there is also trace amounts of ammonia, water, and methane. Methane is what gives it that kind of blue-green color. And it also has 2 narrow sets of rings and 27 moons. All of its moons are named after characters from mainly Shakespeare's works. That's just a fun fact. And the other really interesting thing about Uranus is that it orbits on its side. So like typically, right, planets have, an axis that kind of goes like this, or maybe it's on a tilt. No, Uranus's axis is almost tilted at a full 90 degrees. And it rotates very, very slowly around that axis. That's why the orientation of its rings are completely opposite from what you would see for Saturn. And we think that maybe the reason its orbit is so bizarre is because something collided with it during the early solar system and essentially knocked it over. This image here was taken by the Hubble Space Telescope. This is not like a real color image. This is one that has been done with false color, just to point out different sections of the image. And then we have Neptune, the last of our outer planets. Neptune is located a whopping 30.1 astronomical units from the sun, meaning it is 30 times farther from the sun than Earth is. And it has an eccentricity in its orbit of 0.011 and an albedo of 0.290. And we also classify it as an ice giant. Although interestingly, there's a lot more going on with the atmosphere of Neptune than there is Uranus. In fact, Neptune also has a giant storm similar to Jupiter's Great Red Spot storm. Neptune also has a big storm that tends to appear and disappear over time that scientists call the Great Dark Spot, because scientists are really creative with naming things. And here's again a size comparison of Earth and Neptune. Okay, So again, Neptune's atmosphere, it's mostly hydrogen and helium with trace amounts of methane. And again, methane is what makes it blue. But methane is what makes Uranus and Neptune look blue. However, as you probably could tell from the images, Neptune's blue is much, much more vibrant. Uranus is almost kind of like a tealy blue-green. And we have no idea why that is. Based on what we know about their atmospheres, there's no reason that we know of for the color to be different. Which means there's some unknown component, likely in the atmosphere of Neptune, that is causing it to look so vibrant. And again, it's questions like this of why is Uranus and Neptune different colors, which is why we really need to send another mission out to the outer planets. Because again, like Uranus, only one mission has ever visited Neptune, and that was the Voyager 2 flyby. Neptune is also known for having the fastest winds in the entire solar system. And it also has a very thin set of rings. And you can see these rings here in an image from the Voyager spacecraft. Neptune has 14 moons in total. Triton is the largest moon of Neptune, and it's a very interesting one because it's the only large moon in the solar system that orbits or that circles the planet in a direction opposite to the planet's rotation. So most of the time, right, like if a planet is turning, to the right, the moon orbits to the right. Well, Neptune, still going this way, but Triton orbits in the opposite direction. And scientists believe the reason that Triton orbits in this opposite direction is because it was an object that Neptune just grabbed with its gravity. So originally, Triton was probably just out in the solar system doing its own thing, but it got close enough to Neptune that Neptune's gravity just kind of trapped it and made it its own moon. And so I decided to include this really pretty image from Voyager 2 of Neptune and Triton as a crescent. All right, so we have a little bit of time. So I want to just kind of quick peek at dwarf planets here. Mainly because I'd love to talk about the definition of a planet. Because, it was probably close to 10 years ago now that the IAU, the International Astronomical Union, got together and changed, or really more likely clarified, the definition of what they classify as a planet. And the AIU says that for something to be classified as a planet, it's got to do three things. It's got to orbit a star. In our solar system, that means the sun. It's got to be big enough that gravity has made it have a spherical shape. And it's got to be big enough that its gravity was strong enough to clear its orbit of any objects of similar size. And dwarf planets tend to fail this third category. So a dwarf planet, it orbits the star, it's almost always spherical, but it's so small that it hasn't been able to clear other objects out of its orbital path. And we will talk about the specifics of the 5 dwarf planets that we know of so far in our solar system on Wednesday.